Assalamu alaikum. My name is Abdul Midalvi and I am going to present my topic of design and analysis of algorithm. I am going to present an algorithm topic which is coin change minimum coins. My group members are myself, Abdul Moeed and Fahad Ashraf. Fahad Ashraf is not available in this video because his arm got fractured in an accident and he is not able to join this video because of his injury. If we move forward to the introduction of coin change problem is a classic dynamic programming problem in which a set of coin denomination is given along with a target amount. Our objective is to determine the minimum number of coins which are required to fulfill our target amount, in which we assume that the coins which we have means the number of coins of an array we have are unlimited, means infinite in supply of each denomination is available. If target amount cannot be formed using the given denomination, the solution report that is not possible. If we talk about the problem of the coin change, in this we have given a coin demonstration and a target amount. The coin change problems aims to determine the minimum number of coins required to make the given amount. Each denomination can be used an unlimited number of times, means each element can be used unlimited number of times. If it is not possible to form the target amount using the given denomination, the problem report no solution. Here we have an input, output and example. In this, here D1, D2 and D3 are our denominations. First talk about what are denomination. Denomination here is the value of coin that is available to use. Means it is a value which we can use in our problem. D1, D2, D3 are denominations. And there is one more rules for here for denomination, that it must be unique. Means D1, D2 values cannot be same, and D1, D2 are D3 and Dn are infinite in numbers. Here we want to achieve a target amount, minimum number of coins. Let's see example. Here we have three denominations, 1, 5 and 10, and the amount which we want to achieve is 17. Here we have different ways to achieve the amount 17. First, we can, if we check how many ways we have to achieve 17, let's see, we can use 1 rupee coin 17 times to get our target amount, or 2 times 5, 3 times 5 rupees and 2 times 1 rupees coin to achieve our target amount. But if we use 17 times 1, it will cost more, it will use more storage and cause more use of resources. But our target is to minimize the use of our resources. If we use 117 times, it will lack our resources and we have to more resources to achieve this amount. But this we have to use minimum to achieve our target amount. To achieve minimum, we can use 1 10 rupees coin, 1 5 rupees coin and 2 1 rupees coin. Here we did the same thing and we can achieve our goal 17. This is simple. We have a given array of numbers. This is our array in which we have elements 1, 5 and 10, and here 1 is infinite, 5 is in infinite amount and 10 is infinite amount, and want to achieve a target which is 17 using minimum number of times this infinite coins. So move to next slide. Here we have application where we can use our this technique. We can use this technique in automatic vending machines. Here, how we can use this technique in our automated vending machines. Let's suppose we put 15 rupees in fifth sorry 15 rupees in a vending machine and purchase a 20 rupees of chocolate from the vending machine. Now the vending machine has to give us 30 rupees of change. How it can give us change? There are multiple ways of giving 30 rupees. Like suppose it can give us 31 rupees coins or 32 rupees coin, matlab two coins, 2 rupees coins 15 times, but it will cause a lack of too much of our storage. It can seem and it's also become a burden of on us to handle such big amount, right? Because it takes a lot of storage. We cannot put it inside our pockets easily and it will cause a weight. Or it can only give us 30 rupees or not, which is easy for it to manage and for us to manage. We can also use it in ATM and banking systems, cashier and billing system, currency system design, resource optimization problems, and the final one, game development. Now let's talk about the factors on which our algorithm depends. It depends on exclude, include, and minimum. We have a separate formula for exclude at which we just copy the value of the above cell. We use these three factors from the row 2. We don't use these factors from the row 1. We will get its proper and understanding and clarification. Sorry, it's a tongue twist only. Clarif clarification in next slide. Okay, here we now in the next slide of the DP table. Here we will use these three formulas here in the row 1 and 2. We will not use these formulas in row 0. First we determine how we get the number of rows. Here our number of rows are depend on number of coins. Here we have 3 coins of 2, 3 and 5. So our number of rows becomes 3. Now the number of columns depends on target amount, which is W plus 1. So here we have target amount of 10. So number of columns becomes 11. We start from 0 and goes up to 10, which becomes 11. Now check how this table gets filled. First, to check for only for row 1, we are doing it physically without any formula or coding technique first to get a better understanding of this algorithm. First, if we have 2 rupees and we have to give 0 rupees to a shopkeeper, what will we do? We just don't give him money. If we don't give him money, he gets a 0 rupees. So we type 0 here. But what if we have to give 1 rupees to a shopkeeper, but we have only coins of 2 rupees? Is it possible to give 2 rupees to a shopkeeper? Is it possible to give 1 rupees to a shopkeeper if we have a coin of 2 rupees? No, it is not possible. So what we will do in this scenario? In this scenario, we will write an unexpected value or means a value which will never come to our program or our result, a large amount of huge value. Here I write 10 power 9, which will never ever come in our result. To full to currently fulfill this condition only. Now if we move to the next point, if we have to give 2 rupees to a shopkeeper, can we give? Yes, we can give 2 rupees to a shopkeeper. And how many coins we use is 1. I have 2 rupees and I want to give a 2 rupees to a shopkeeper. So how many coins I have to give him? I have to only give him 1 coin of 2 rupees. Now can I give him 3 rupees using a infinite number of 2 rupees coins? No, I cannot give him 3 rupees. So I again write a value which will never come into my result, which is 10 power 9. Now can I give him 4 rupees? Yes, I can easily give him 4 rupees using my 2 rupees coin. And how many coins I have to give him to make 4? I have to give him 2 coins of 2 rupees to get a value of 4. Can I give him 5 rupees using 2 rupees coins? No, I cannot give him, so I use again 10 power 9. Can I give him 6 rupees using 2 rupees coins? Yes, I have to give him 3 coins of 2 rupees to get the final result of 6. Here I write 3 because here is our coins 2, right? Again same result for 7, 8, 9, 10. Right? If I want to give him 10 rupees, I have to give him 5 coins of 2 rupees. So here I write 5. I cannot give him 9, I can give him 4. Okay, now comes to an interesting part and the most critical and tough part of this program and DB table is starts from the row second. Now here our three factors are using. Here we are using our previous three factors. These three factors exclude, include and a function which will get minimum values from exclude or include. Exclude just call as get copy the above cell. Here if we have a coin value less than our column value, then we use the terminology of exclude. So here just use copy the above cell 0, 10 power 9, 2. Now, what if our coin becomes equal to 3? Here we will use the formula of include, exclude and minimum. We will find the value of exclude, which is copy the above cell, and then find the value of include and then put him in this function to get the minimum value, and we will write this minimum value here. So what we have, the exclude value here is 10 power 9. So exclude becomes 10 power 9. Now find the include using this formula. Now we have the formula of include dp row, which row we have 1, col minus coins row, which column we have 3, minus coins row value is 3, which becomes 0, plus 1, 0, dp row 1, and we have value of 0 is 0, and if we add 1 here it becomes 1. So which is, here it comes 1 and here comes at exclude comes 10 power 9. So which is small is 1. So we is simply write 1 here. Simply if we check for 2, then we again use the same terminologies of first find exclude, then include, then minimum. Exclude tells us to copy the above cell. When we move to the next row, we can use the previous values. That's why we are using exclude. So if we copy the above cell, so here exclude becomes 2 because at this point 4 has a value of 2. Exclude becomes 2 and then find include using this formula. So what if we minus cols row means 4 minus 3 becomes 1. At 1 1 we have 10 power of 9. Sorry, it becomes 1 4 minus 3 becomes 1. At 1 1 we have 10 to the power of 9, and if we add 1 in it, it becomes simply 2, which is 10 power of 9. So which is small is 2. So we simply write here is 2. Same method will fills our this whole table, and we will use this again and again until we reach to our final destination point. So now let's move to its algorithm. Here we have coins, which is representing array and representing number of elements, and W is representing the final value. Here we are filling the first value. Here we know that row is equal to number of coins and column target amount plus 1. Just new, here is our number of rows, here is column, we are adding 1 according to our formulas, and this whole is representing our only first row, this row, and this will represent our onwards rows, second, third, fourth to n, means this one. Oh, okay. So here we have a for loop which runs until our column values get less or equal to W to fulfill our first row. If call modulus coins equal 0, then divide the column with and write value at that element of the column. Here we are filling first row, so we use 0. Else write an unexpected value which will never come to our result. Now for second row we have two for loops, upper for loop, outer loop and inner loop. Here we use our exclude and include terminologies, use again include formula which we learned here and implement in this table. Then find the minimum values and write at that point. Now return the values again. Here we have a code demonstration of our code. First here we have a code with proper commands. Then execute this code. Now we are writing denominations values. We are writing the same values 2, 3 and 5, and write the target amount 10. Here we get a value of minimum coins used is 2 and coin used are 5 and 5. Like we use, so minimum number of coins to get the value of tens are 2, which are 5 and 5, and our code is representing the same thing. We use minimum coins 2 and which are 5 and 5, so our code is running excellently. Now move to the next slide. Sorry, we have just a little bit crash issue of not responding. Let me fix this issue. Oh no 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 no. Now let's talk about the flowchart of this program. Is our program starts, take inputs of denominations and get a target value. Initialize our first row, check amount for each coin value C. If yes, then execute this. If no, execute this point, and then it programs repeat until the value of I. Then again check addition. If yes, it ends. If no, the loop starts again and check the minimum values and bring and terminate the program. Now we have two for loops to find target amount. Here we have a time complexity. We have two loops, outer loop and inner loop. Means for outer loop I runs from 1 to a, means runs a times. For inner loops I iterate over n coins, run n times. So our time complexity becomes order of na times. Space complexity here becomes order of a and order of na times. So here's the final part and the conclusion part of our program is the coin chains minimum problem is a classic example of dynamic programming in which the goal to find the minimum number of coins required to make the target amount using a set of given denominations. The problem demonstrates important DB concepts such as optimal substructure and overlapping subproblems. This problem has numerous practical applications in real-world scenarios such as vending, ATM, billing, currency systems. By solving this problem using dynamic programming, one can achieve a time complexity of OA order of NA times and space complexity of order of A times. In short, we have summary the coin change problem not only provides a foundation for learning dynamic programming but also illustrates how algorithm thinking can optimize every day. Thank you for your time. Allah Hafiz. This is it for today. Khuda Hafiz.